Hey guys, it's Mrs. McLean, and today we are going to be talking about our quadrilaterals. So I want to go over a few vocabulary words really quickly to make sure you understand what different classifications of quadrilaterals are. And basically, to be a quadrilateral, you have to have 4 sides and 4 angles. Now, inside that quadrilateral family, there's also the trapezoids. Now, trapezoids, again, have 4 sides, but they only have 1 pair of parallel sides, which means if these lines went on forever, would they ever hit each other? Top and bottom would not. They're parallel. But if I looked at that left and right, they would end up hitting each other, which means these are not parallel. So this would be a trapezoid since there's only 1 pair of parallel sides, and that's the mathematical notation for parallel. Now over here, they don't have to always give you that notation. They could write it in words. So over on the side, you can see AB, and then they've got those 2 long lines next to each other. Well, that's the mathematical symbol for parallel. So I know AB is parallel to DC. Now notice this time I didn't use 1 arrow, I used 2, but as long as they're the same, it's showing me those are the 2 that are parallel to each other. Now inside, again, that quadrilateral family, there's also the parallelograms, which means 4 sides, but they have to have 2 pairs of parallel sides. So again, right here you can see these sides are parallel to each other, and these sides are parallel to each other. And that's what's considered a parallelogram. So again, in words, MN is parallel to PO, and MP is parallel to NO. Rectangle is another quadrilateral. It also has to be a parallelogram, which means it has to have 2 parallel sides, but it also has to have 4 right angles. So if you look at that first one, that's definitely a rectangle because I can see the parallel sides, 2 pairs of them, but I can also see that symbol for the right angles in all 4 corners. Now this other one does not have the 4 right angle symbols, but it does show me, since they all have that same number of little curved angles, they are all exactly the same. So even though they don't have the 90-degree symbol, doesn't necessarily mean they're not 90 degrees. I just have to prove it because it doesn't matter what it looks like, it's what I can prove. And if all of them are the same, when I divide the 360 degrees inside that quadrilateral, that does come up to be 90 degrees. So yes, this is also a rectangle because it does actually have 4 right angles. And, of course, like I said, it also has 2 pairs of parallel sides. There's also the rhombus family. Now again, the rhombus is saying that yes, you have to have 4 sides. Yes, you have to be a parallelogram. You have to have 2 pairs of parallel sides. But you must also have 4 congruent sides. I don't care about anything inside. I don't care about the angles. It's only are all 4 sides exactly the same length. So these hash marks right here, if they're all the same amount of hash marks, that means they are congruent. They're the same. So that does have 4 congruent sides. I can also see that it does have 2 pairs of parallel sides. So I know it is a rhombus. Again, 2 pairs of parallel sides, and all 4 sides are exactly the same. All 4 sides are exactly the same, and there are 2 pairs of parallel sides. Again, I don't care about those 90-degree angles inside. They don't mean anything to me if I'm looking at if it's a rhombus. Now, special one here in the quadrilateral family is if it is a parallelogram, 2 pairs of parallel sides, and it is a rectangle. which means it has 4 right angles, and it is a rhombus. All the sides are exactly the same. Well, then I can call it a square. Now, even though this looks like a square right now, you can't say it's a square unless you can prove it. So again, if it had symbols on it or words telling you that it had 2 pairs of parallel sides, well, I could call it a parallelogram. If it actually had 90-degree symbols, or you could prove they were each 90 degrees, then I could call it a rectangle. And only if they gave you the fact that all sides were the same could I call it a rhombus. And if I can say it is yes, 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 and yes, then it's called a square. Now, just like yesterday when we talked about triangles, the triangle sum theorem said every triangle had 180 degrees inside. Well, quadrilaterals don't have 180. They have 360 degrees inside. When I add up all 4 angles, it comes up to be 360. Why? Well, yesterday we learned that every triangle has 180. But I'm showing you right here, there's all my 4 quadrilaterals in red. But every quadrilateral is actually made of 2 triangles. So if I have 180 degrees here with that triangle, 180 degrees here with this triangle, that's going to give me a total sum of 360 degrees. Again, 180 in this triangle, 180 in this triangle. Inside, it is a total of 360 degrees, and that's called the quadrilateral sum theorem. So knowing that, could we find, if I gave you a quadrilateral with a missing angle, could you find that missing angle? Well, just like yesterday with our triangles, yes, we're going to go ahead and add all of our known angles. You know 3 of them, so 115 plus 65 plus 55. When you add those all together, you come up with 235 degrees. And then, if I go ahead and know that 3 of them are 235, I only need to subtract that from 360 to find the one missing angle. So 360 minus my 235 is going to tell me that missing angle is 125 degrees. Now I can make it a little harder. This time I'm giving you a quadrilateral. I'm not giving you 1 missing angle. I'm giving you 2. And the fact is, they're not even the same. So if they're not the same, what I'm going to do is I'm going to write an equation showing that when I add them all up, it's going to be 360. So let's take all 4 angles, 135 plus 35 plus x plus that x plus 30. When I add them up, I have to have 360. Now, if I can combine like terms, which we've done many times before, put all my variables together that are the same, that's going to give me 2x. And now add that with my combining like terms of my constants. And when I add 135 and 35, it's 170 plus 30 is 200. That's going to give me still my 360. And now I'm going to isolate the variable. So let's go ahead and remove our constant by doing the inverse operation on both sides, creating my 0 pair. And that simplified gives me 2x is 160. Continue to isolate the variable by removing that coefficient, dividing 2 on both sides, creating that giant 1, which leaves me with x equals 80. You just found 1 missing angle. That x is 80 degrees. The only problem is I didn't give you 1 missing angle. I gave you 2. The other angle that was missing is x plus 30. Well, you already found out what x is. X is 80. Add that with the 30 and the other missing angle, 110 degrees. The last thing I want you to be able to do is to classify your quadrilaterals. And when you are going to classify, I want you to find the best name to classify it. And again, don't base it on what it looks like, only what you can prove. So if I look at A, there's 4 sides. I can prove that. Now, is it a trapezoid? Is there only one pair of parallel sides? Well, I'm not sure. I better look at the words below before I even start. So XY is parallel to Y or WZ. So I'm going to put that parallel symbol here. I also know that XW is parallel to YZ. So that shows me 2 pairs of parallel sides. So that's a parallelogram. Now look at the angles to see if I can call it a rectangle. Well, inside, I can see these are the same, but these are different. So it is not a rectangle. Are all the sides exactly the same? No. I've got only 1 hash mark on top and bottom, 2 on the side. So unfortunately, the only thing I can actually call this, the best name is just a parallelogram. Now on B, let's see what we've got. MN is parallel to QP. So let's put those parallel signs on there. MQ is parallel to NP. So that's different. So those are parallel to each other. So 2 pairs of parallel sides, automatically a parallelogram. Now let's go ahead and look at those angles. They are all exactly the same. So if they're all exactly the same, 360 inside divided by 4 means they're all 90 degrees. So this so far is a rectangle. Now, a rhombus means that every side has to be the same. Well, I only see 1 hash mark on every side, which means every side actually is congruent. So since it is all a parallelogram and a rectangle and a rhombus, I know the best name is a square. I hope that answers some of your questions on quadrilaterals. If not, make sure you write down those questions to bring to class, and I will